Welcome back, children. We are going to have the next chapter, Linear Equations, Module 2, Session 1. Hope you all have gone through all the 13 sessions of trigonometry which we did earlier. Please keep practicing sums. Now we are going to the second module. This particular module is on linear equations, and today is the introductory session. Okay. Now, what is an equation? What is a linear equation? These two things are the major questions arising out of your mind. You would have been introduced to linear equation right from class 6 onwards. You just come across and you are very familiar with equations of the type 4x is equal to 3. So what is x is equal to? What is the meaning of 4x equal to 3? It is 4 times x is equal to 3. So 1 time x, what should we do? We have to divide by 4 and get the answer as x is equal to 3 by 4. This is a very basic form of linear equation. Even in the last chapter, you would have studied about polynomials. So we are going to have the next module on polynomials sooner. But the polynomials, as you studied in your earlier classes, enough for you to understand now. A polynomial is an expression in x and y connected by means of the operations addition and subtraction, multiplication and division. Okay. Now, in these polynomials, the literal numbers and the variables are connected by a relationship. That is what you studied in your earlier chapter. An algebraic expression equated to some value is called an equation. Can you give an example of an equation? Don't be always thinking about the type 4x is equal to 3 and 3y is equal to 6 and so on. Go a little further. Even this is an equation, 4x plus 4xy plus 2x is equal to 5. This is also an equation. If you write this as 4x square plus 3x square is equal to 7xy, that is an equation. Any expression equated to something we call an equation. Now there is a variety of example we can quote for this, but our knowledge is to restrict to only linear equations. What do you mean by linear equations? What is the term? What mean linear? Means what? Linear means it is single or one. You would have studied a polynomial with varying degrees in your last chapter or in your earlier classes. When you were introduced to polynomials in your 7th and 8th, we had taught you how to classify them as monomial, binomial, trinomial, quadrinomial and so on. But in this class, in this session, we will be learning how to classify the polynomials in terms of its degrees. So when I introduce the term degrees, you should know what is the degree of a polynomial. Okay. Now, when I write 4x is equal to 3, the power of x is just 1. Therefore, it is one type of equation. When I write 4x square is equal to 6, this is some type of equation in which the variable x has got a power of 2. Can you find the difference between these two categories? This is the power is 1. This equation has got the power as 1. So we have to give a name to it. This is an equation with power 2. We have to give a different name to it. Now, is it restricting to only 1 degree and 2 degrees? No. You can have even the degree as 3, 4 and 5 and so on. So, according to the degrees, we have to definitely classify the equations. This is the first and basic point that you have to understand. And like a polynomial or like an algebraic expression, an equation also can have different degrees according to the degree of the variable. So in this section or in this particular class, you will be learning about the equations in which the variable has got only one power. Now, in this, our knowledge is going to extend little further. So that is what we are going to see now. So what did I tell you? When you write 4x is equal to 5, always you should notice the power of the variable. Here the power of the variable is 1. Therefore, it is a linear equation in which the variable has got only one power. Okay. Now, when I write 3x square minus 2 is equal to some 15 say. So, when I write like this, the power of the variable is 2. We can even simplify this equation. So 3x is equal to, this 2 goes to the other side. All the other rules are as it is. You are very familiar with that. Okay. Now if I write x cube is equal to minus 1. So what happens to the degree? The degree of x is equal to 3. Therefore it's a cubic equation. So like that we can create a number of equations in which the degrees of the variable vary. It may be 1, 2 or 3 or x power n. X power n is equal to some value, say 8. So we can create a number of equations in this manner. Okay. Now in this class we are going to restrict ourselves to dealing with equations which have the variable as only 1. So you don't have to worry about it. Different types of linear equations you have studied in your earlier classes. Can I give some example or get some examples from you? Can you tell me some examples? Yes. It is 2x minus 1 is equal to some 8. So you would have quoted this example. This is also a linear equation. Somebody would have suggested 2 into x minus 5 is equal to 6. This is again a linear equation. So you would have suggested 3 into x plus 3 is equal to 3 into x minus 4. I can hear some equations from that corner. It is of the type 2 by 3 of x is equal to 4 by 5. So this is also, all these are classified as linear equations about which you would have studied last. I will come to the practical aspect of linear equation little later. So this is the very fundamental form of the linear equations. One thing you would have noticed, in all these cases there is only one variable, namely the variable x. We have involved only one variable. Even though there were 1 or 2 examples in your earlier classes in which you used linear equations and then solved problems. Especially when you studied coordinate geometry. Now, what is it? So bring it back to your memory. When you involve one more variable also, what will happen? You get a new set of items called linear equations in 2 ways. So when you involve 2 varying quantities, it is called a linear equations in 2 variables. So you had studied about this in your earlier class. You have to bring it back to your memory. How these are connected. How do we interpret a linear equation in 2 variables in a step-by-step manner. Okay. Now, very fundamental question I am going to ask. So, can you give an example of a linear equations in 2 variables? Remember, while giving the example, I want you to get the examples in such a manner that the variable's degree is 1. Yes, 2x plus 8y is equal to 6. It's an example. Anybody else? Yes, what you have suggested also is right. 3x minus y is equal to minus 3. Can anyone else quote one more example? Yes. X minus 2 by 3y is equal to 1 by 16. This is also an example. Anybody else? Yes. It is 5x minus 2y is equal to minus 9. So all these are examples for linear equations in two variables. Have you understood? So how do we interpret it? See, it establishes a connectivity between x and y that 2 times of one variable, 8 times of another variable gives the sum as 6. Here in the second, can you interpret it? 3 times of one variable, from that we are subtracting 1 time of another variable to give the answer as minus 3. And then the third one, from one variable you subtract 2 by 3 times of another variable y to give the sum as 1 by 16. Yes, can you interpret the fourth one? Yes, I know you are ready with the answer. What you have thought is very correct. 5 times of one variable from which we are subtracting 2 times of another variable to give the difference as minus 9. Have you understood that? Now I want you to thoroughly examine the equations once again and be ready with your answer, which I am going to ask you now. You had given this example, 2x plus 8y is equal to 6, 3x minus y equal to minus 3, and x minus 2 by 3 times of y is equal to 1 by 16. Now, when you look at this, what is your first impression? You tell me. It gives a representation. The second also gives a representation. Third also gives a representation. Fourth also gives a representation. Are you all convinced with this? It may be anything. Here, when you look at this equation, first equation, 2 is a constant, 8 is a constant, 6 is a constant. Now, when you represent this as 2x plus 8y is equal to 6, that gives a representation I told you. In that representation, can we change the values of 2, 8 and 6? So definitely no, they are all fixed numbers. What can you change here? Yes, y. Why? Because they are variables. For you, x and y may be something. For you, x and y may be something else. For the third person, it may be different. So, in whatever be the example, the connectivity is what? 2x plus 8y is equal to 6. So, you can even call it as a function, isn't it? There is a connectivity or a relationship. X and y are connected by means of this relationship. Now, if it is so, I want you to ask one particular question. Are the values of x and y be fixed for an equation? Is it only one value which can satisfy this relationship? I just want you to think and answer. The connectivity of x and y is in this manner we have represented. If it is the case, shall we have only one set of values to satisfy this relationship? Think and tell me. Yes, I heard somebody saying it is so unique. Think and tell me. Is it so unique? Somebody said it is not so, 2 values. Somebody said 3 values. Somebody said 4. Not so. 2x plus 8y equal to 6 means it can be anything. It has got a wide range of values. Y has got wide range of values from minus infinity to plus infinity. All real numbers we can quote. Similarly, y also all real numbers we can quote. But the connectivity is this relationship. Likewise, we can think of many x and y's. Are you getting it? Now, I'll just write down for one particular value. I will tell you 2x plus 8y is equal to 6. And same way we can establish with a different set of values so that 2x plus 8y is equal to 6. Can we try like that? Now, let us take the easiest example in this and then we'll find out what will happen, and then we can apply and generalize, or we can induce it for other equations also. 2x plus 8y is equal to 6. And still you have a doubt. Why I am saying that the values of x and y are not unique? Now, I want you to quote whatever value you want for x. Somebody said 0. Shall we work on that? So, 2 into x plus 8 into y is equal to 6. So, x should take the value 0. So, it has to satisfy for some y, isn't it? So, it is 0 plus 8y is equal to 6. Therefore, 8y is equal to 6. Y is equal to 6 by 8, which is going to give you an answer 3 by 4. That is, when x takes the value 0, y is taking the value 3 by 4. So, this relationship exists. Yeah. One of you suggested the value -1 for x. Okay, why not -1? Yes, we can have. So, 2 into -1 plus 8y is equal to 6. Correct? So, it is -2 plus 8y is equal to 6. Now, this -2 goes to the other side. So, what do you get? 6 plus 2. So, 8y is equal to 8, y is equal to 8 by 8, giving the value 1. So, what have you got? When x is equal to -1, y is getting a value +1. Are you understanding? So, corresponding to one value -1, there exists another value y as 1. Is that clear to you? Somebody said unique. Are you okay? It is not unique. Let us see, is it limited to some set of values? Okay, we can quote some fractional values. You can quote an integer value, or you can quote any real value for x. We will get a corresponding value y. Shall we try with one more example? Someone suggested some fraction value for y. Why don't we have fraction value? Yes, we can have. So, 2x plus 1 by 8 you suggested. I'll go by that. So, 8 and 8 cancels. We will get 2x plus 1 is equal to 6. 2x is equal to 6 minus 1 equal to 5. So, x is equal to 5 by 2. That is, when y is equal to 1 by 8, x gets a value 5 by 2. So, this is one set. Someone else suggested 0 for y also. So, we can have 0 for y this time. So, you get 2x plus 8 into 0 is equal to 6. So, 2x is equal to 6 by 2, you get 3. Therefore, y becomes 0, then x will become 3. So, this is one set of values. By looking at all these 4 examples, what do you understand? I want you to infer some point in that. Shall we find out? You have to tell me what are the interpretations that you have formed in your mind. Shall I list down? Yeah. By examining all these rounded values, we can make a number of interpretations. I want you to list down the points one by one. Okay. Come on, tell me. The first interpretation is the values of x and y is not unique. X and y can take any value. Number one. And second, there is always a value corresponding to a particular value of x or y. Meaning, when you assign a particular value for x, we can always get another value for y. When you assign a value for y, we can always get some value for x also, because they are connected by means of this relationship. That means choosing of x value is also infinite. Getting the values of y also is infinite. Therefore, the values of x and y is infinite. The values of x and y is infinite. There can be any number of values we can think of for x and y. Correct? So this is second interpretation. Third interpretation is what? One more interpretation which you can adapt from what you have learnt in your earlier classes. Can anyone tell me? Just because there is a correspondence for the values of x and y, all these values can be, plotted on a graph sheet. Are you getting it? Because of this correspondence, all these x values, y values, they can be plotted on a graph sheet in the Cartesian plane. Okay, so there is a connectivity for the graphical representation of this relationship. Okay, something more I want. What kind of representation is this? What kind of representation is this, children? Remember from what you have studied in your earlier class. It is a straight line, a linear equation in one variable with x and y is a straight line. We can plot it on a graph and you get a straight line. So all these things you studied in an earlier class. Now, let us find out in what way it is having a practical implication in your real life. Because anything and everything you studied in the high school in maths has got a connection in your real life situation. Somewhere or the other you have to use these things in your real life. Otherwise, it is only theoretical. So why should we study? That question will linger in your mind. For that, let us find out how do we apply it in real life. Let us represent a very simple linear equation and learn how is it connected into your real life. Here, 2x plus 3y giving you 8. Now, 2x plus 3y is equal to 8. Here, you are going to a shop. You buy some item for ₹2. Or how many items? Anyway, we can fix either 2 or x. Suppose if I take the cost of the item as x and cost of an item as some other item as y, you are going to a shop. Okay, you are buying 2 items for x rupees, for x amount. It can be a rupee or it can be even a paise or whatever it is. Okay, don't worry about it. And you buy a second item. The cost of one item is y. We represent as y. And you buy 3 items. So, 2 numbers of the first item with cost x and 3 items with cost as y, together you have to give the shopkeeper an amount of 8 rupees. Yes or no? It can be 8,000 or whatever it is. X thousand and y also may be in thousands. It doesn't matter what it is. Okay. So it's just a representation to give you the total amount to the shopkeeper. The same example can be quoted in different way. You are going to an exhibition where you come across lots of items. You manage to play 2 rides with the cost of X rupees for each ride. So 2 rides of the same cost X. Some other rides with Y as the cost, 3 rides you went. So totally you have spent rupees 8 or 8,000 or 8 tens or 800s. It may be. Okay. So the total cost is given as 8. This is another example. Can anyone think and tell me the third example? You are going to a library. So number of English books or the cost that you have to, the lending charges for a particular book is X, and then for next type of books is YC. So in that case, 2 numbers of category whose lending charge is 8, whose lending charges is X. So you bought 2 items. And similarly for the second category, you bought 3 items. You got us 3 items. So totally you have to give 8. Okay. Now again, you are going on a tour. Okay. So with the speed of X kilometer, you went for 2 hours. So the distance here. And then with the speed of Y kilometers, you traveled for 3 hours. So in that case, the total distance traveled is given by this equation 8. 8 kilometers you traveled. So what is the value of X and Y? So like that, you can connect this representation with. Now look at this example. 2x plus 5y is equal to 18. I want you to connect with a real example. You are traveling a distance of 18 kilometers. You just on a holiday. Okay. You are just planning to go for a distance of about 8 kilometers. With a speed of X kilometers, you travel for 2 hours. With a speed of Y kilometers, you traveled for 5 hours. So the total distance is 18 kilometers. So it may be walking, it may be cycling, it can be you go on a bike, or that doesn't matter at all. Here X and Y represents the different speeds with which you reach the 18 kilometers is what we want. Are you understanding? So this way you can quote a number of examples on different situations. So the linear equations is very much connected to your life. Or even you can consider age. You and your little brother, 2 times of your age and 5 times of your little brother's age together gives you a number 18. So what is the age of yourself and your little brother? So that way we can connect. So it is very practical, and we have to know how to apply it in real life situations. So linear equations, as a single equation, we can consider too many solutions or too many values for X and Y. Now, I am going to write another equation. X plus Y is equal to some 10. I have written like this. So this is a different linear equation by itself. Isn't it? This is a different equation by itself. So you consider both the equations separately. This equation has got infinite solutions. This equation has infinite solution. But when you put them together, there should be some common value. Okay. with which both have the same solution. Or in other words, there is some value x and y which is satisfying both the equations, both the relations. So if that is the case, can you have infinite number of solutions for it? If you consider both the equations together, okay, now we are not considering as a single equation. We are considering both the equations together. You are going to talk about some particular value which is a solution for both the equations. That means that x and y can be one of the solutions for this and also can be one of the solutions for x and y also. Okay. Now, will that be unique or infinite or double, or what can you say about it? Can anyone tell me? Can anyone tell me? It is unique. Why it is unique? We cannot have a number of solutions for two equations. Okay? Why? The geometry is coming to your help. I told you from your earlier knowledge, 2x plus 5y is a straight line, is a representation of a straight line. Similarly, x plus y is equal to 10 is a representation of another straight line. There is a common value means that common value which satisfies both the linear equations must be a common point on both the lines. Is it clear to all of you? Bring it back to your memory what you have studied in your earlier class. That common value is the common solution for both the equations and that has to be unique. Why? Because that point is a point common to both the straight line representation, and we all know the fundamental principle of geometry that two lines will intersect at only one point. If you take your x and y values, you can plot a straight line like this. Similarly, with the values of x and y, you draw some other straight line and this common point is a point on both. This is a point on both. Therefore, it has to be unique. Why? Just because it's a common point, we can always interpret that both the lines are intersecting at one point and the two lines will only intersect at only one point. Therefore, the common solutions is so unique. Are you understanding? This is what you have to give a deep thought and understand, and this session is aimed at teaching you that the solutions of two linear equations is so unique. There is only one particular value which will agree for both the equations, and that point we call it as the common solutions for both the equations.